use it to calculate what is the power factor absorbed by the load. It is very easy to calculate what is the power factor of each load you can calculate, but using 2-watt meter method it is very easy to measure the power factor of the total load. So in that point of view, we have small derivation part based on phasor diagram, so that I am going to take that entire discussion. And yesterday I stopped at this point only after discussion of phasor diagram. Again, I am recalling the same information, the same method. So here I'm going to use 2-watt meters W1 and W2 to measure the power factor as well as total power, and also we can calculate reactive power using 2-watt meter method also. So let us see how possible these active power, reactive power and power factor and all other, how to calculate that we can discuss now. So first of all, I'm assuming the load is balanced. So that here I'm assuming is the load is balanced. So when the load is balanced, it means the phase currents or the line currents in a star connected network or their magnitudes are same. That means IR is equal to IY is equal to IB is equal to IL, where IL is the line current. So this is the IR value. We can call this is phase current as well as line current because it is a star connected network. Well, coming to VRN, VYN, VBN, or say V phase. So those are phase voltages. So that here it is the ERN. So I can take this is VRN, this is VBN, this is VYN. Let the impedances are balanced. So therefore, their magnitude and phase angles of three impedances are same. That means Z1 is equal to Z2 is equal to Z3 because it is to be balanced. Since the line voltages, suppose if you want to write the line voltage VRY is nothing but VRN minus VYN, VYB is nothing but VYN minus VBN, VBR is nothing but VBN minus VRN. But here we are connecting 2-watt meters only for R phase and Y phase, but their voltage coil is connected to commonly B phase. So the current coil is connected to the R phase, that too in series with the load. Voltage coil is connected across the load, that too R and B phase. Coming to the second wattmeter, the current coil is directly connected in series with the load, that is in connection of Y, but the voltage coil is again connected with respect to the B phase. So that both the wattmeters currents are IR, the next wattmeter current is IY. But both the wattmeters voltages are, the first first wattmeter voltage is VRB, because the voltmeter which is connected, that's the pressure coil, is always connected to the B phase. So VRB. And now the second wattmeter voltage will be obviously VYB. So to measure current, to measure the power in a first wattmeter, definitely we have IR, VRB. To measure the second wattmeter reading, the required currents and voltages are the IY, VYB. So with these two calculations only, we can calculate what is the total power absorbed by the load and also what is the total reactive power absorbed by the load. From there, how to calculate the power factor, that is cos pi. So per individual phase, we can calculate power factor, but totally, what is the total power factor of the system, that we can calculate with the help of 2-watt meter method. So here the first wattmeter reading, we are assuming W1 is IR and VRB. So VRB is a line voltage because it is a potential difference between two lines. How to define this line voltage in terms of phases means you look at this one. VRB is nothing but vector difference of or vector sum of VRN minus VBN. Or also you can write this is in terms of plus, that is VRN plus, then I have to reverse this sequence VNB. VNB. Therefore, either you can write VRN minus VBN or else VRN plus VNB, both are same. While coming to the second wattmeter voltage is VYB. So it is also nothing but the potential difference of both the phases VYN and VBN. So suppose if you want to take it is a plus, then alter the terms B and N terms. Therefore, you will get the total value. So we have to calculate VRB, VYB, and we know IR and IY. Again, we have to bring the relationships. That means to calculate the power, definitely we need to calculate the angle between current and voltage. So which current and which voltage angle we are going to calculate, that I can show here. So coming to the first wattmeter reading. What's the first wattmeter reading? So the first wattmeter reading is W1. So I can write over here. So what is W1? I can write over here. So the first wattmeter reading is W1 is equal to, what is the current through the first wattmeter reading? IR. So therefore, I can take this as IR. What is the voltage of the wattmeter? VRB. Then we need to calculate the power factor. That is nothing but cos of, because there are two terms IR and VRB. We don't know the angle between them. So that we have to calculate that angle. Let the angle is pi or pi 1. So what is pi 1? It is an angle between both the current and line voltage. That is IR and VRB angle. Similarly, what is the second wattmeter reading? So the second wattmeter reading, simply I can take W2. So therefore, I can write W2 is equal to, what is the second wattmeter reading current? IY. So therefore, the second wattmeter reading current is IY into, what is the voltage? VYB. Then what is the power factor? So therefore, cos of angle between these two, let the angle is pi 2. So what is pi 2? It is an angle between IY as well as VYB. Now how to find angle between IR and VRB, IY and VYB using phasor diagram? That is what yesterday we had discussion, right? Now again, I'm going to recall the same information. So we need to calculate angle between these two, IY and VYB, IR and VRB. So this is what we are going to find. So to find the angle between these two, if we find the angle between them, then we have pi 1 is some value, pi 2 is some value. Therefore, wattmeter reading W1, wattmeter reading W2, we should know. From that, we can calculate total power absorption is nothing but total power P is equal to sum of both the wattmeter readings. That means W1 plus W2. So this is what we are going to calculate. Once we calculate total power absorption, calculate angle between both line current and line voltages. That means IR, VRB, IY, VY. About this information, once if you understand the phasor diagram, that explanation is over here. So first we need to draw the vectors. That means VRN. That means phasor vectors. So you can have, if you have free space there, you can understand. Right, here I can draw. So we are having three phases. Let the three phase voltages are the, let this is the first phase voltage is VR, VR, n. Now the next phase always will be 120 degrees phase shift. So this is V, Y, N. And the next phase will be phase shift is 120 degrees. I can call this is VBN. Three phases are displaced at 120 degrees to each other in a three-phase balanced system. Now, what are the negative vectors for the given value? So I'm going to draw the negative vector for this VBN. Therefore, I can take this as minus VBN, or also you can write plus VNB, whatever it is. See here I'm using loads Z1, Z2, Z3. So three loads are inductive loads we are assuming. If three loads are inductive loads means the current through the respective loads IR, IY and IB always lagging the supply voltage by certain angle of pi. So the first current is IR, which lags the supply current by some angle. Let the angle is, this is IR. So the angle lagging behind them is pi. Similarly, IY lags VYN by an angle of pi, same angle. Similarly, this is nothing but IB. This is nothing but IB lags the supply voltage by angle pi. Now, how to calculate the line voltage? Because we required only two line voltages, VR, VY. In this way. So both vectors can meet at this point. So if I join the vector over here, I will get this vector is like this. So this vector, what is the plus VRN, minus is VBN. Therefore, I can take this is the line voltage VRB. Similarly, for VYN with respect to minus VBN, so I'm going to use one more vector in parallel with VBN. Again, one more vector in parallel with VBN. So again, we have one more line voltage over there. This line voltage, I'm going to take VYB because Y is a positive, B is negative over here. So this is a line voltage. Now, generally, what is an angle between these two? So per phase voltage value, displaced at 120 degrees means the angle between the one positive phase and negative phase is 60 degrees, right? This is 60 degrees. Now what is this angle? Obviously 50%. That means 30 degrees. So this angle will be 30 degrees. Similarly, while coming to the next previous one, I'm going to take one more different colors, right? Now, what is the angle between VRN and minus VBN is nothing but this is 60 degrees. Now, what is an angle between VRB and VRN? So, obviously, this total length is 30 degrees, right? But what is our requirement? We are going to calculate the angle between these two. That means VRB as well as IR, VYB as well as IB. Sorry, IY. So therefore, let us coming to here. What is the angle between IR and VRB? That means the required angle to calculate the power factor is what is an angle over here. So I'm going to take the different colors. There you can understand. Let us see this one. Now, what is an angle between these two? Right. What is the angle between these two, IR and VRB? So what is the angle of this one? Obviously, if it is pi, if it is 30, definitely it should be 30 minus pi. Now, what is the angle between next to wattmeter? That means IY and VYB. So in this, these two. What is the angle between these two? Already 30 is there, plus pi is there. Other wattmeter reading power factor should be 30 minus pi. So that we are having only two, 30 plus pi, 30 minus pi. That depends upon connection of your wattmeters as well as, based on the connections. That means the current and voltage of the wattmeters. I hope you understand. So whatever discussions there, here also we have same discussion. So I'm going to calculate angle between these two. That means IR and VRB. Actually, the angle between VRN and VRB is 30 degrees. Angle between IR and VRN is pi. Now I'm going to calculate angle between these two means 30 plus pi. Sorry, 30 minus pi. Coming to this vector, second wattmeter. So this is all about W1. For W2 wattmeters, so what is an angle between IY and VYB? These two. So the angle between IY and VYN is pi. VYN and VYB is 30 degrees. Therefore, obviously we can take the angle between both IY and VYB, which should be pi plus 30 or 30 plus pi. So here, thus the phase angle between VRB and IR is 30 minus pi. Similarly, the phase angle between VYB and IY is 30 plus pi. Therefore, the two readings of the wattmeter should be, that is the first wattmeter reading is W1 is equal to, or P1 is equal to whatever. So P1 is equal to VRB into IR into cos 30 minus pi, or I can take VL into cos 30 minus pi, because VRB is nothing but a line voltage, so that I can take VL. IR is nothing but either line current or phase current in a star connected network. Therefore, I can take IL. So VL IL into cos 30 minus pi. This is the first wattmeter reading. Then what is the second wattmeter reading? P2. Here is second wattmeter reading. Voltage is VYB, current is IY. Now the angle between them is cos of 30 plus pi. Similarly, VYB is the line voltage, IY is the line current. Therefore, the second wattmeter reading in terms of line voltage and current is VL IL into cos 30 plus pi. So that everyone should remember these two equations only and forget about either it is W1 or W2. Keep in mind, so whatever wattmeter readings, one wattmeter reading is always cos of 30 plus pi, and other wattmeter reading should be always 30 minus pi. That is, if you connect wattmeters to the any phases, definitely you can get the same relation. So that everyone should remember these two formulas, VL IL cos 30 minus pi for 1 wattmeter, it may be 1 or 2. VL IL cos of 30 plus pi for other wattmeter, it may be 1 or 2, whatever it is, that is your issue. Now, what is the total power consumption of the load? So the total power P is equal to sum of both the wattmeter readings. So when I add both the readings, VL IL cos 30 minus pi plus VL IL into cos 30 plus pi, there I can get the total power consumption is root 3 VL IL into cos pi. How this can be achieved, that I can show here. If you know the formula for cos A minus B and cos A plus B formula, then if you apply the formula, we'll get the answer. Let us see. whether it is correct or not, that I can check now. Right. Coming to this one. What is the total power consumption? I am going to calculate P. That means P is equal to add both the wattmeter readings. That is P1 plus P2. When I add both, VL, IL is a common terms. Therefore, I will take common. VL, IL is common. What is the first one? Cos 30 minus 5. So what is formula for cos A minus B? Can anybody?
Cos A into cos B.
Cos A, wait, cos, wait. Right, cos A means 30. So cos A into cos B, that means cos pi.
Plus sin A into sin B.
Plus sin A. What is A? 30 into sin B, sin phi. Okay. Plus, what is the second wattmeter? That is cos 30 plus pi. What is the formula for cos 30 plus pi? Can anybody? Cos A plus B. Previous one is cos A minus B. Now it is cos A plus B formula. Nobody can answer. Anyone respond?
Yes, sir.
Cos
Cos
A,
A, cos B,
cos
Cos A,
A,
cos B minus sin A, sin B, sir.
good, minus sin 30 into sin pi. This is sin pi. Okay. Now simplify the expression. I will get this is VL IL into what is value of cos 30? What is the value of cos 30?
Root 3.
root 3 by 2.
Good. Root 3 by 2 into cos pi is same. There is no doubt. This should be cos pi plus what is sin 30?
1
1
by
by 2.
1 by 2 into sin pi plus again cos 30 into cos pi, same, root 3 by 2 into cos pi. Here it is minus of same value, right? So plus and minus will be cancelled. Therefore, the reading of the given system is, that means VL IL into root 3 by 2 cos pi plus root 3 by 2 cos pi. What's the value? After simplification, if I take root 3 by 2 common, cos pi plus cos pi, right, very good. It should be
Root 3 cos.
root 3 cos pi. Now, our expression is correct. That is root 3 VL IL into cos pi. So this is the way how to calculate total power consumption of load when it is to be balanced. The load consumed by, that is the power consumed by the load is root 3 times of VL IL into cos pi. So if you know the formula to find A plus B, that is cos A plus B, cos A minus B formula, there you can understand. So how to calculate. But anyhow, for the exam point of view or any other competitive exam point of view, you have to remember the standard equations for the 2 wattmeter method. That is the first wattmeter reading or second wattmeter reading, whatever it is. Always 2 wattmeter readings are the one of the wattmeter reading is VL IL cos 30 minus pi, and other wattmeter readings should be VL IL cos 30 plus pi. You just keep in mind only those two equations and don't by heart everything. You just keep in mind this equation and this equation. It may be P1 or P2, whatever it is. I can go with this is P2 or I can go with this is P1, whatever it is, you just keep in mind those two values that will help you to calculate power factor at different loads, at different power factors, what is the total power consumption, each and everything you can find with the help of only two equations. So you have to remember these two equations. Now when I do P1 minus P2, that means VLIL cos 30 plus 30 minus pi minus of VLIL 30 plus pi. When I do like that, that means P1 minus P2. If I do like this, the first term, that is cos 30 into cos pi, here is minus cos 30 into cos pi should be 0. Therefore, obviously, you will get there is a reactive power, that is VLIL into sin pi. Therefore, if I multiply this total equation with respect to root 3, I get the reactive power, that is QT is equal to root 3 times of P1 minus P2. This expression also we can obtain. That means when you subtract both the wattmeters, that means when you do P1 minus P2, obviously you will get the value is VLIL into sin pi. Therefore, the total reactive power consumed by the load should be root 3 times of that value. So, what is the total power consumption of the load should be always P and is equal to sum of both the wattmeter readings P1 plus P2 or W1 plus W2. This is the total power consumption. The total reactive power consumption should